about an amusement park consisting of rotating circular platform, 11.1 diameter, from which 10 kg seats are suspended at the end of 2.41 meter massless chains. When the system rotates, the chains make an angle of 14.5 degrees. There's an angle, and you guys have seen this ride in an amusement park. It's rotating around, and the seats kind of move up, and we have riders sitting on here. Question is, what is the speed of each seat? Again, we know, and if you've seen any of these, if you ever rotated something like this, the faster you rotate it, the larger these angles become. So the information they give us on the angle should tell us something to do with how fast it's going. How do we take this apart? Well, our first thing we're going to do is make a free body diagram. So if I were looking at this object right here, it has tension from the chain pulling in this direction and gravity pulling down here. There's T. And so this angle here, which is theta, would also make this angle theta. These are alternate interior angles. And so if you see that tension has two components, one that is basically balancing out gravity. I'll draw it a little bit larger here so you can see it. Here's T. Here's the angle theta. And then here's mg or fg. And so this component of tension has to equal to the weight. So we have T cosine theta equals mg. This makes it pretty easy for us to find the tension right away on the string. The idea is, again, we have tension acting in this direction. One component is here, which is basically balancing our gravity, and the other one is what is causing this circular motion. Is this component of tension plays the role of the centripetal force needed to keep this object going around in circular motion. And so T sine theta must equal mv squared over r, where this is the centripetal force and is being supplied by this component of tension, while this one here is counteracting with gravity and balancing it out. So our net force on this is, of course, for any circular motion, we know the net force always acts towards the center of the circle. Now this one is, of course, moving at a constant speed, and we want to see what this would be. And so if I were to look at these two equations, I can first solve for T really quickly. T would just be mg over cosine theta. Let's go ahead and physically calculate that out. The mass of each seat is 10 kg, so it'd be 10 times 9.8 divided by cosine of 14.5. And that gives me a tension of 101.22 newtons. Now that I know what the tension is, I can go ahead and use it in this equation here to find my V. Now, there's another thing you want to pay attention to is what is R for us? Our R is the distance from this part of the seat to the center of rotation. Well, that's not just this part, it's also that part there. This whole thing is D, so half of this is D over 2. And so R would equal to D over 2 plus this little part right here, which if this distance is L, and that is the opposite, that would be L sine theta. So this only little twist here is that R is going to equal to this expression here, because that is what RR is. And R is, by definition, the radius of the circular motion. Our circular motion is going around in this direction on that plane. So now I could say that T sine theta equals mv squared over d over 2 plus L sine theta. And so now I could go ahead and put values in. I have 101.22 times sine of 14.5 is equal to 10 times v squared over L, which is 11, L is 2.41. This is 11.1 is the diameter. If I divide that by 2, I get 11.1 divided by 2 is 5.55. So that would be 5.55 plus L, which is 2.41 times sine of 14.5. And so on the left-hand side, times sine of 14.5 gives me 25.45, sorry, 25.34 is equal to 10 times v squared over, I'll calculate the bottom part there, 5.55 plus 2.41 times sine of 14.5. And so this is 6.1534. So v squared would be 25.34 times 6.1534, all divided by 10. All I did was take that over there, bring the 10 down. And so v would be the square root of all of that, which is 25 times 6.1534 divided by 10, and then so that would be the square root of 15.6, which is 3.95 meters per second. Okay, so that's the speed at which this is rotating, so that gives us this angle of 14.5 degrees. So that's part A. The speed of each seat will be 3.95 meters per second. The next question says, if a child of mass 63.8 kg sits in the seat, what is the tension? Well, the tension, of course, we looked at was just mg over cosine theta. They want it to be for the same angle, and so the tension would be the mass of the child plus the mass of the seat, in which case this would be 63.8 plus 10, or 73.8 kg, divided by cosine of 14.5. And so then if I do that, I have 73.8 divided by cosine of 14.5, and that gives me 76.22 newtons. Okay, so that would be the tension on the seat when it's at this angle. And oops, I forgot to put the 9.8 here. Whoopsie, whoopsie, whoopsie. Put it up there, so I need to multiply this by 9.8. Sorry about that. I just kind of went right for the mass and forgot putting the G over there. Don't make those mistakes. So times that with 9.8, and so that's not right. That gives me 747.03 newtons. Okay, I should have probably seen that right off the bat when I saw a small number like this, with the kid being 638, close to, 600 newtons right there. 76.2 newtons just wasn't making sense at all. Okay, so that's how we find the tension. I hope this helped, and see how we could solve an interesting problem like this. I could just as well have turned this thing around and said, if the speed is, you know, 10 meters per second, what's the angle going to be? And so you could obviously work it out with this expression right here. All you'd have to do is now be solving for the angle. You could multiply both sides, solve for theta, and figure out at what angle you would get to do that. But key part is using the free body diagrams, understanding this is circular motion, and using these relationships that we formed to do our question. Okay, to work through it. All right. Well, that's the end for this question. I'll see you again next video. Bye for now.